not done this yet. This is the type of math that looks really ugly in the middle, and then it turns out really pretty. So don't get scared if the middle part of the problem is ugly. That's okay. But it's going to turn out pretty in the end. So we're going to do synthetic division by an imaginary number. You do it the exact same way. Every single time we bring down the first one. And every single time we multiply. But this time we're multiplying 2i times 2, which gives us 4i. And now we add. But when we add -1 and 4i, we can't really put them together. What it makes is a complex number. The real part comes first, the imaginary part comes second. And that's what it looks like. So see how it's getting a little ugly right here in the middle? The middle gets ugly. Yeah. All right. So now we have to do the same thing. We multiply this 2i times this. And I'm going to come over here and do this on the side. 2i times -1 plus 4i. So we're going to need to distribute here. So when we do a 2i times a -1, that gives us -2i. And now we're doing a 2i times a +4, which is a positive 8i squared. Does anybody remember what I squared is?
It's a -1.
It is a -1. So it turns this 8 into a -8. So when I write it right here, it becomes -8 minus 2i. The real part comes first, the imaginary part comes second. Okay, it's still a little bit ugly, but at least the 8 goes away now, because 8 minus 8 turns into 0. And all I'm left with here is -2i. Now, I do the 2i times a -2i. Yes, it is -4i squared. Well, what does this I squared do? It makes it +4. Okay, which is awesome because I get 0. And that is my check step. Getting a 0 right here lets me know I'm doing something right. Okay. Now, all I told you was 2i is a root. And that's not enough. But the weird thing about imaginaries is if 2i is a root, its conjugate has to be a root too. So if 2i is a root, then you automatically know that -2i has to be a root too. And I'll show you in a minute why that has to work. The only way to get this imaginary was to have this to start with. Excuse me. And so to get that 2i, I had to take the square root of -4. And when I take the square root, don't I always get a positive and a negative? That's why if 2i is a root, -2i has to be a root. Just has to. Alright, so this is still a little ugly, but this is where it all cleans up. It's going to be so pretty at the end. We bring down the first one, and then we multiply. -2i times 2 is -4i. Oh, what happens to my imaginary part right here? Goes away, doesn't it? And then -2i times a -1 is a +2i. So what happens to that imaginary part? It goes away. Alright, so this -1 is my plain old number. which tells me that this is my x. So this is just a binomial, 2x minus 1. There's no square this time. There's no extra third one. So if we set this equal to 0, is that pretty easy to solve? You add 1. And divide by 2. So if I had to list all the roots of the equation, or zeros of the function, depends on how they word the problem, roots of the equation, zeros of the function, they're the same thing, it would be the 1/2, the 2i they gave me to start with, and then the negative 2i. There they are. Okay, so now I'm going to prove to you that this works, but I'm going to show you by doing a method we've already done. Now, this method doesn't always work. I stuck it in here as the first one on purpose so that I could prove to you using a different method that it's the same thing. I could actually, and you don't have to do this, you don't have to write this down. I could do 4-term grouping with this problem by dividing it up 2 and 2. And I could take an x squared out of this, and it leaves me 2x minus 1. And I could take a positive 4 out of this, and it leaves me 2x minus 1. So this becomes 2x minus 1 times x squared plus 4. And what did this x squared plus 4 right here, I did it just a second ago, when I solved it, do you see you get the other two? So this would factor through the x plus 2i and the x minus 2i. And so we could do the same problem by factoring. Now, that does not always work. It did for this one, just because I wanted to prove to you that these could come from what we already know. All right, and let's go ahead and do number 2. Okay, so if 3i is a root, what am I going to divide by the second time? Negative 3i. So I already know I can divide twice. Okay, I'm not missing any degrees, so I don't need any zeros. I just need a 3, a 2, a 27, and an 18. I don't know if you can tell, but I spaced these out really far because I just need more room when I'm dealing with complex numbers. Is that almost straight? Okay. It's hard to do a straight line from this side. Okay. So here we go. You always bring down the first one. And then we're going to multiply. So 3 times 3i is 9i. And then we're going to add. So we can't really put them together. We just get 2 plus 9i. And then we're going to multiply. Well, I need to show my work so I don't get confused. So I'm going to put it over here to the side. So I'm going to show that I am multiplying 3i times 2 plus 9i. And that craziness gives me 6i plus 27i squared. But what does the I squared do to that? Good. So this gives me a negative 27 plus 6i. So what happens to the 27s? They cancel out. It's getting prettier. We're not there yet, but it is getting prettier. And then a 3i times a 6i is 18i squared which becomes what? Negative 18. Negative 18. So I did it. I got my 0, so I know I'm on the right track. Okay, so now we do the same thing, except this time we're using, that didn't need to go that far. This time we're using the negative. So we bring down the first one. This is where things clean up nicely. Then we multiply. And then we add 2. And then we multiply. And then we add 0. So we brought it down, we multiplied, and when we added, the i's canceled. And then we multiply, and we add, the i's cancel. And that's going to happen every time you do synthetic division by a number, by imaginary number, and its conjugate. You get all this crazy stuff in the middle, but then all the imaginaries go away the second time you divide. Okay? So this is my number, and this is where my variable goes. So if my last one is 3x plus 2, and I set that equal to 0, so to solve it, I would just move the 2 over. Did anybody besides me see somebody sprinting down the hallway?
I wasn't looking.
Okay, and then we divide by 3. Good job paying attention to my teaching. Alright, so if I ask you for all the zeros of the function, or all the roots of the equation, depending on how we word the directions, it's negative 2/3, and then you were given 3i, and then negative 3i is your other one. Okay, we're going to do one more together, and then I'm going to let you try number 4 on your own. Looks like all you guys are taking awesome notes today. Give you a 5-day weekend, you come back refreshed. No? That wasn't enough time?
No.
I woke up Monday morning thinking that we had to go to
Wild
school.
morning.
Yeah, Monday morning and Tuesday, I thought we had to go to school. I woke up at 6 o'clock.
I just wait. I just wait.
Alright.
AKA Madison.
Now, number 3 has a trick to it, because it's missing one of the degrees. What has to go in there when we're missing a degree?
0.
A 0. So we've got a 4th one, 4th degree. We've got a 3rd. We're missing the squared. So this is where the 0 goes. Now, if you start working on your problems in class today, and you're like, something's not working out, I'm not getting my 0 right here at the end like I know I need to, go back and check. That's the first thing I look for. Did I need to plug in a 0 as a holding place, and I forgot to? Alright, so we bring down that first one. We multiply. And then you add. This is where it looks a little weird because it becomes complex right here. We get negative 4 plus I. I never really cared for this middle step. Now I gotta multiply the I times the negative 4 plus I. And when I do, I get negative 4i plus I squared. Very good. That I squared is negative 1. So this becomes negative 1 minus 4i. Okay, so when I add 0 to that, it doesn't even change.
4. Isn't the variance supposed to be positive because it doesn't come to that?
I'll get them in just a second. Alright. Now we have to multiply the I times this. And this is 4I here. So this becomes negative I minus 4I squared. And that I squared makes this a positive 4. So it becomes a positive 4 minus I. So now those cancel, I'm just left with negative I. And then I times negative I. I times negative I is negative I squared, which is the opposite of negative 1. What is the opposite of negative 1? Positive 1. And I got my 0. It worked. Okay, so if I is 1, what's the next thing I divide by? Negative I. And this is where it gets pretty. So I bring down the 1. And I'm going to multiply, and it gives me negative I. So that's just going to leave me with a negative 4. And then I'm going to multiply, which gives me a positive 4I. And that leaves me with a negative 1. And then I'm going to multiply, and that gives me a positive I, which leaves me with a 0. Now this one's not quite as nice. Because this is my x, and this is my x squared. And it doesn't factor. So when it doesn't factor, what do we have to do? Quadratic one. So we do negative b, so it becomes a positive 4, plus or minus the square root of b squared. Negative 4 squared is 16. Not 16 squared, I've already squared it. Minus 4 times 1 times negative 1 all over 2 times 1. What happens when I do minus times a negative? Minus and a negative, what's it going to make? Positive. It makes a positive. So this becomes 16 plus 4. Which is 20. This one problem uses a lot of math stuff that you've learned. Synthetic division, yeah, we're about to. Quadratic formula. And now we can simplify this radical. Because 20 is 4 times 5. What is the square root of 4? 2. And now, do both of these divide by 2? Yes. Yeah! We're finally done. Because this was a 4th degree function, I know that I should have 4 roots. So one of my roots was I. Another one was negative I. One of them is 2 plus the square root of 5. And the last one is 2 minus the square root of 5.
I also just put like 2 plus or minus.
You could. Yes, you could. Okay, I want you to try number 4. Okay? And I'm going to go check. Do you need more space to write? You got more space. Yeah, look at all that. Alright, let me see yours. 4. Okay, so the one I gave you works, but we got some bigger numbers in here. So let's work our way through this. That's not a straight line, but we'll all pretend. We bring down this one, and then we multiply. And we get a positive 8i. And because this was 8, we want to make those cancel, but we can't. Because this is a real number, and this is an imaginary number. So we get negative 8 plus 8i. You cannot let those cancel. Okay. So now we have to do 2i times 8 plus 8i. Negative 8 plus 8i. So this makes negative 16i plus 16i squared. But what does that I squared do? Makes it a negative. So what we have right here is negative 16 minus 16i. And that gives us negative 1 minus 16i. Because the 15 and the negative 16 makes a negative 1. And the negative 16i I can't do anything with. So now I got to multiply this times this. So we have 2i times negative 1 minus 16i. Okay? And that's going to give me negative 2i minus 32i squared. What does that I squared do? Makes it a positive 32. So now I've got 32 minus 2i. So the positive and the negative cancel. And just leave me with negative 2i. So a negative 2i times a positive 2i is negative 4i squared, which is positive 4. And I get my first check step. 0. Okay, so the first line is ugly. The second line cleans it up. So now we divide by negative 2i. This is where it all gets pretty. So I bring down, I multiply. Okay, the second time you divide by an imaginary, all your imaginaries should go away. They do. I multiply. They do. I multiply. They do. Okay? So the second time you divide by imaginary, all your imaginaries go away. Alright, so this is a x, which means this one is a x squared. Okay. So now I've got to do the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So, negative b, positive a, plus or minus 8 squared is 64 minus 4 times 4 times negative 1 all over 2 times 4. This is where you're probably thankful for calculators. This is 64 plus 16, which is 80. So this is 8 plus or minus the square root of 80 over 8. Okay, 80 breaks up into 16 and 5. What's the square root of 16?
4.
4. And do you see that 4 divides into this number, and this number? 4 divides into all of those. So this crazy answer is 2 plus or minus the square root of 5 all over 2. And this is actually two answers, the positive one and the negative one. So this is 2, and then we also have the plus and minus 2i. So that's 2 more. So there are all 4 of the roots. Yes, ma'am.
Couldn't you, when you got 8 plus or minus square root of 80 over 8, couldn't you divide that and it be 1 plus or minus 10 and then go from there?
It looks like you could, but because this one's under a radical, you can't divide something that's not under a radical into something that is. So we have to get it out of the radical before we can do that dividing. That was a good question. Okay. We're going to do one more together. So we're going to skip number 5. And I'm going to let you guys pick. Do you like 6 better or 7 better?
Either.
Fair. Would you rather do 6 or 7? Okay, 6. Today is honesty day, huh? Alright. So we'll do 6 together, even though we'd rather do neither. Alright. I have 1 minus 2i. And it doesn't look like I'm missing anything, so I just have 2, negative 5, 12, and negative 5. Okay, so the degree of this function is 3. It's a third degree function. So how many roots should I end up with? 3. Okay, so good choice, because number 7 has 4. So this one's a little easier. And it's the exact same process, but because I'm dividing by a complex, it might look a little uglier to us in the middle. Still turns out pretty at the end. Same process. Bring down, and then we multiply. So if we do 2 times 1 minus 2i, that gives us 2 minus 4i. So we have to do this times this, and that gives us 2 minus 4i. So just like before, you can only put the real parts with the real parts, the imaginary with the imaginary when we're adding. So all we can do is put the negative 5 plus the 2 together, and that gives us negative 3. And then that negative 4i just hangs out at the end. Please put our phones away. Thank you. Alright, so now we're going to do 1 minus 2i times negative 3 minus 4i. So we have to distribute the 1 and then distribute the 2i. So that gives us positive 6i and positive 8i squared. 8i squared. All right, Mr. Maybe. Okay, so this I squared makes out a negative 8. So this craziness becomes negative 11 plus 2i. That craziness became negative 11 plus 2i.
You might want to change that because it says I on it.
Whatever.
You had it up high.
Oh, okay.
Yeah, it confused me.
Gotcha. Sorry. Alright, so this makes 1 plus 2i. So I got 1 more set of work. Ooh! Do you guys remember what happened when we multiplied conjugates? If we do this times this, aren't we multiplying by conjugates? And what happens is that inside and the outside are going to cancel. We get a negative 2i and a positive 2i. What happens with a negative 2i and a positive 2i? It cancels. So all I have to do is the first one and the last one. And this makes a plus. So what is 1 plus 4? 5. Ding, ding, ding. We have a winner.
Now, do we have to do 1 plus 2i?
That is right. We do the conjugate, which is 1 plus 2i. So if this is 1 minus 2i, the next one is 1 plus 2i. And so we're going to bring down the first one. Why can't I draw a semi-straight line? And this is where the pretty stuff happens. Then we're going to multiply. So 2 times 1 is 2. 2 times 2i is positive 4i. Look at the i's. The i's go away. And then negative 1 times this makes a negative and a negative. And it all goes away. So I got my check step here. I got my check step there. Okay. The x goes here. So this is 2x minus 1. All I have to do is set it equal to 0 and solve. Move the 1 over and divide by 2. So my roots, or my zeros, depending on how they set up and ask the question, are the 1/2 I just found, the 1 minus 2i they gave me, and its conjugate, the 1 plus 2i. And that's all 3 of them. Okay, let me swing by and check and make sure you completed your notes today so I can give you your classwork grade. And that's all we're doing.